Yes, so good morning, everyone. Today we are going to discuss about the chapter 10, haloalkanes and haloarenes. Haloalkanes and haloarenes. So this is the one chapter among this organic chemistry. I think you have learned one chapter based on this topics in +1, right? Hydrocarbons, isn't it, Vidur?
Yes, ma'am.
Okay. Then you have learned the basic things in the 10th standard. Carbon and its compounds, about alkanes, alkenes, alkynes, their nomenclature, right? So here we are going to discuss about haloalkanes and haloarenes. So can you able to relate anything to this term haloalkane? Halo. Okay, what do you mean by alkane? What about the structure of alkane?
The functional group of carbon.
Yeah, which are the groups present in this alkene? Elements. Which are the elements present in alkene?
Methyl.
Yeah, elements means carbon and hydrogen, right? Carbon and hydrogen. These are the main elements present in the case of alkenes. So here it is haloalkanes or haloarenes. So which group will be attached to this alkane? Aditya?
Hydrogen.
Halo. It's not hydro.
Halogen.
Yeah, halogens. Okay. So this haloalkanes, the replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom. What do you mean by aliphatic and aromatic? What's the difference between these two? Adul, can you tell me the difference between aliphatic and aromatic?
Aromatic means benzene and
Yeah,
benzene-like compound.
yes, that's it. What about aliphatic?
I think unsaturated compound.
Yeah, straight chain carbons. Okay, yes, very good. So here this haloalkanes, it is the replacement of hydrogen atom. Instead of hydrogen, we will substitute certain halogens. That's it. Replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon. Aliphatic or aromatic hydrocarbon by halogen atom. Okay, this one is an example for aliphatic compound, I mean straight chain compound. Aliphatic hydrocarbon. Morning, sir. Aliphatic hydrocarbon. What about aromatic hydrocarbon, children? Aromatic. Yeah, benzene is an example for aromatic hydrocarbon. Okay, so the replacement of this hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom. It is known as haloalkanes or haloarenes. This is clear? Replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atoms. So what are the halogens? Which group is known as halogens in the periodic table? All of you switch on your videos. Dia, can you tell me which are the halogens present in the periodic table? Just try it. Yeah, group
13.
with 13 halogens. There are 18 groups in the periodic table, right? 18th one is noble gases and the 16th one is chalcogens. So can you tell me which one is halogen? Or any example for halogen? No idea? Emmanuel, can you try?
72.
Very good. Group 17. Okay. Group 17 is known as halogens. Which are the members in group 17? Okay. Group 17. They are known as halogens. Chlorine, bromine, iodine, fluorine, these all are known as halogens. So you have to remember group 17, they are known as halogens. The members of this group 17, they are fluorine, chlorine, bromine, iodine. Okay. So in the case of this haloalkanes and haloarenes, the position of hydrogen, it can be replaced by any halogens from this group. If it is fluorine, it is known as fluoro. Okay, fluoro. We will learn the nomenclature. That means the naming of these compounds. So you have to remember for fluorine, we will write fluoro. Then for chlorine, it is chloro. Then for bromine, it is bromo. And for iodine, it is iodo. So the difference between aliphatic and aromatic hydrocarbon, in the case of aliphatic hydrocarbon, it's a straight chain carbon. Okay, it's a straight chain carbon with no double bonds or triple bonds. There is only single bond there. In the case of aromatic hydrocarbons, they are ring structure with alternate double bonds there. Okay, in both cases, in aliphatic hydrocarbon and aromatic hydrocarbon, this hydrogen, it is replaced by certain halogens. They are fluorine, chlorine, bromine, iodine. I mean, we will name this elements fluoro, chloro, bromo, iodo. This is clear, children? Any doubt there? Michael, switch on your video. Naurin, Rijas, Evelyn, Punya, Muhammad Adim, Srihari, Aryan, Malavika, Meenakshi, all of you switch on your videos. This is clear, children? Okay, then you already learned the naming of alkanes. So we can just try one example there. Okay, alkanes or aliphatic hydrocarbons. We can start from the basic. Yes. Try its name. Here it is CH3, CH2, 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 CH3. What about its name? Do you remember, children, about its naming? If only one carbon atom, which root word we will use? One carbon atom.
Meth.
Very good, meth. For one carbon atom, it is meth. What about you? Which one? Yes. Very good. Yes. Then for 3. For 3. Vidur, 3. Try. For 3. It's prop. Okay. Prop. And for 4. It is bute. Okay. 4, it is bute. Then 5. 5, you can, yeah, pent. Very good. Pent. Then 6. Which one?
Hex.
Very good. Hex. Then what about 7?
Sept.
Which one?
Sept.
Hept. It's hept. Okay, then 8. 8. Oct. Then 9. 9. None. 10. Deck. You have to remember this names for each numerical. Okay, 1 it is meth. For 2 it is eth. Then for 3 it is prop. 4 it is but. 5 it is pent. 6 it is hex. 7 it is hept. 8 oct. 9 none. And 10 deck. So in the name of all alkanes, we will use this root word plus ain. Okay, root word plus ain. So look at the number of carbon atom and tell me what will be the name of this organic compound.
Pentane.
Yeah, it's pentane. Pentane, because 5 carbon atoms are there. 1, 2, 3, 4, 5. Then we can do one more example there. CH3, CH, CH3, CH2, CH3. What about this one? In this example, there is one substituent, right? This one is considered as substituent. There are certain rules for this naming of this compounds. You have to find out the longest chain as parent chain. Okay, longest chain as parent chain. Then you can categorize other things they attach to this parent chain as substituents. Okay, then you have to name the substituents first. Then you have to write the parent chain. So this group, it is one carbon group, right? One carbon group. It is known as methyl. Okay, or methyl. Yeah, Achut?
We have to give the number also, right?
Yeah, number also. Yes. So you can also number it from here because the substituent will get lowest number. 1, 2, 3, 4. There are 2 options there. You can start from left to right or from right to left, right? 1, 2, then 3, 4. But the correct method is from left to right in this example because the substituent has to get the lowest number. Clear?
Yes.
So what about the name of this compound? I told you we are using methyl, ethyl, propyl, butyl like that for the substituents. Okay, instead of ain, we will use yl, methyl. Okay, methyl. So first you have to mention the now position of the substituent. So what will be the number there?
2.
Yeah, it's 2. Then after 2,
Methyl.
yeah, methyl or methyl. Then you can write the parent chain. What about the parent chain?
Butane.
4 carbon atoms, right? So it is butane. 2-methyl butane. This is the name of this compound. This is clear, children?
Yes, sir.
All of you? So these are the basic things that you already know. Then we can move to this haloalkanes and haloarenes. So what is this haloalkane and haloarene? Which group is substituted there or which group is replaced there? Meenakshi, can you tell me?
Halogen.
Yeah, halogens replaced which atom? Yeah, from the straight chain, which atom is replaced by this halogen?
Hydrogen.
Yeah, very good. Hydrogen. So we can see here, there are different hydrogen atoms here, right? In the case of haloalkanes or haloarenes, they will replace the position of hydrogen. That's it. Okay. Okay, then one more point you have to note. In the case of haloalkenes, they are single bonded molecules, right? So they can be always in sp3 hybridized state. They are in sp3 hybridized state or sp3 hybridization. All single bonds, they are always in sp3 hybridization. Then in the case of haloarenes, they have double bond, right? So they are in sp2 hybridization. sp2 hybridization. Haloalkanes, they have only single bonds, so they belongs to sp3 hybridization. Then haloarenes, they have double bonds, so they are in sp2 hybridization. You have to remember this point always. Then the main uses of this haloalkanes and haloarenes, they will use this solvent. They will use this solvent for non-polar compounds. Okay. Solvent for non-polar compounds. In the case of this non-polar compounds, they will not dissolve in water. Okay. So instead of water, we will use this haloalkanes and haloarenes. Used as solvent for non-polar compounds. Then as a starting material, for synthesis of organic compounds. For synthesis of organic compounds. There are many types of organic compounds that you will learn in chapter 11, 12, 13, etc. Aldehydes, ketones, alcohols, phenols, ethers, amines. These all are organic compounds. So this haloalkanes or haloarenes, it is considered as a starting material for synthesis of this organic compound. So these are the main two uses. They are general uses. So it's clear, children. Haloalkenes, they have sp3 hybridization due to their single bond. Then haloarenes, they have sp2 hybridization due to double bond. Because in the case of benzene, there is alternate double bonds, right? Here it is single chain. Okay. We are going to learn about some important haloalkanes and haloarenes with its use. Okay, important haloalkanes and haloarenes with its use. Have you completed the slide? All of you? Yes, right? Okay. Then the first one is chloramphenicol. Chloramphenicol. Can you tell me, is it belongs to which category of medicines? I think you all are familiar with this one. Say medicine, then which type of medicine? Chloramphenicol. Any idea? Biology students? Switch on your videos, children. It's a chlorine containing antibiotic. Okay. Chlorine containing antibiotic. It is used for the treatment of thyroid fever. Sorry, just wait, just wait. Typhoid fever. So it's a antibiotic and the halogen present in this one is chlorine. Okay. Chlorine is the halogen present in this antibiotic. It is known as chloramphenicol and it is used against typhoid fever. The next one is thyroxine. Thyroxine. It's an iodine containing hormone. Iodine containing hormone. And it is used for the treatment of goiter. It's a disease that happens due to the deficiency of this iodine, right? So it's a iodine containing hormone that's treated against goiter. E-T-E-R, goiter. Chloramphenicol, it's a chlorine containing antibiotic. It is against typhoid fever. Then thyroxine, it's an iodine containing hormone. It's against goiter. Then a synthetic halogen compound. Okay, synthetic halogen compound is chloroquine. Chloroquine. It is used against malaria. Malaria. Thyroxine, chloramphenicol, then chloroquine. Then one more, it is halothane. Halothane. It is used as an anesthetic. These are certain important haloalkanes and haloarenes. They have certain clinical uses.
Ma'am,
Yeah, Chu.
these are the examples for
Haloalkenes and haloarenes. Okay, and they are clinically useful compounds. This is clear now? Yes. Then the next part of this chapter, that means 10.1, classification. It's not included in the syllabus. It's deleted. Then one more portion in this chapter that's deleted. That is page number 317, polyhalogen compounds. It's also deleted. Classification, then polyhalogen compounds. It's 10.1 and 10.7. These are the deleted portions. All of you switch on your videos. Rija, Sevelin, Srihari, Malavika, Nia. So now we are moving to the nomenclature. Nomenclature means naming of this organic compounds. So you can write the heading nomenclature. Can you tell me which organization will provide the rules for naming this organic compounds?
IUPs.
Very good. IUPAC. Okay. That is International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. They will officially declare the names of all these compounds. Okay, they will give certain rules for the naming. And there are two types of names for each compound. Okay, one common name and one IUPAC name. Okay, one common name and one IUPAC name. So now you can tell me which are the halogens, examples for halogens. Mehak, examples for halogens.
Fluorine, iodine, bromine.
Chlorine, yes, fluorine, chlorine, bromine, iodine. These are the examples of halogens. So first we can check how this common name, it can be derived. Okay, common name. Naming the alkyl group, naming the alkyl group followed by the name of halide. Okay, naming the alkyl group followed by halide. Halide means halogen, which is the halogen present there. So I will write one example here. The CH3, CH2, CH3. Okay. Then instead of this hydrogen, I will just remove one hydrogen and write one halogen. It is haloalkane. Okay. Instead of one hydrogen, I will write one halogen, bromine. So what will be the common name of this compound? CH3, CH2, CH2, Br. What about the common name? I told you the naming alkyl group followed by halide. So which is the alkyl group present here? There are 3 carbon atoms. So which is the alkyl group? Yes.
Propyl.
Yeah. Propyl or propyl. Propyl. Then which is the halogen? Which is followed by halide. So which is the halogen here?
Bromine.
Yeah. So it will end as propyl bromide. Okay. It will end in bromide. Propyl bromide. I told you about iodo, bromo, chloro, fluoro. That we will use in IUPAC name. IUPAC name. That's it. So this is the pattern of common name. Naming the alkyl group. It is followed by halide.
Ma'am,
Yeah.
ma'am, in the textbook, N is N propyl.
Yeah, N-propyl. That is, there are different types of propyl groups. If it is right, it's straight chain, we will use N. Okay, and if it is in the form of different chains, that means there is one substituent there, we will write isopropyl. Okay, so it depends upon the position of these 3 carbon atoms. If it is in a straight chain, we will use N-propyl. That's it. So after this common name, we can learn how to write the IUPAC name. Okay, IUPAC name. It should be write as halo substituted hydrocarbon. Halo substituted hydrocarbon. That means we will write the position of halogen first, then the name of halogen, then the parent chain. That's it. We can write the IUPAC name of the same compound, CH3, CH2, CH2, Br. What will be the IUPAC name of this compound? CH3, CH2, CH2Br. We can do the numbering. It's from 1, 2, 3 because the halogen should have the least number. Okay. So what will be the name of this compound? CH3, CH2, CH2Br. Aditya, can you please try?
Ma'am, one bromo.
Yes, very good. 1 bromo. Then how many carbon atoms there? 3, right?
3.
Yeah. So propane. Okay. 1 bromopropane. 1 bromopropane. You can use this one capital. Okay. 1 bromopropane. In the case of common name, we will name the alkyl group first. It is followed by halide. In the case of IUPAC name, it's halo substituted hydrocarbon. So we will start with halogen. It is followed by hydrocarbon. And also remember to show the position of this halogen. This is clear? Okay, then we can do one more example to write the common name and IUPAC name. Yes. Can you please try the IUPAC name and common name? The exams, there will be questions to write the IUPAC name or its structure. When the name is given, you have to draw its structure. But these question, I think only 2 mark question from all these chapters. Chapter 10, 11, 12, 13. These all comes under organic compounds and there will be 2 mark question from this nomenclature part. But you should learn that. Yes. Can you tell me its name? Michael, can you tell me its IUPAC name? Yes.
Ma'am,
Yeah.
last one can you show me?
Which one? Previous slide?
Yes.
Yes.
Okay, ma'am.
Okay. Michael, tell me. Yes. IUPAC name. Which one?
3-chlorobutane.
I told you there are two possibilities for numbering, right? From left to right and right to left. But you should remember the substituent should get the least number. So is it 3, Michael? Yeah, 2, right. Okay, 2-chlorobutane.
Ma'am,
Yeah, Achut.
it should be CH3 at the end. Right?
Yes, sorry, CH3.
CHCl.
Yes, yes, yes. Yeah, you have to remember about the valency also. Carbon, its valency is 4. So at least 4 carbon bonds are there. CH3, CH2, CHCl, CH3. So 2-chlorobutane. Then what about the common name? Common name. Gauri, can you please try?
Isobutyl chloride.
Here it is known as secondary butyl chloride. Leave that part. It's okay. It's butyl group, right? This no, this butyl group with straight carbon, it is known as secondary butyl. Okay, secondary butyl chloride. You have to learn to write the IUPAC name. It's important than common name. Okay, but you should know there are two names there: common name and IUPAC name.
Ma'am, so
Yeah.
also it's not needed.
No, no. Here it is secondary butyl. In the case of propyl group, if the 3 carbon chains are in straight line, it is known as propyl group. Isopropyl. Okay. Yes. Sorry, N-propyl. N-propyl. It's depending upon the position of this halogen attached to the straight chain. I think that you will understand by looking at the examples at page number 291. First one is N-propyl bromide. Here the bromine is attached to the last carbon. Then next one is isopropyl chloride. Here is the chlorine is attached to second carbon. Like that. No need to worry for that. Common names. You should follow the rules of IUPAC name. That's more important. Okay, then one more example. What about the IUPAC name? There are 2 bromine atoms here. So you have to mention the number also. Vidur, what about its name? Yes. Yeah, tell me. It is 1, 2, 3, 4. The numbering from both sides will be equal, right? Because the positions of this bromine group, it is always 2, 3. So, what will be the name? 2, 3. Then dibromo butane. 2, 3 dibromo, because there are 2 bromine group here, right? So 2, 3 dibromo butane. Okay, now it's time to wind up the class so we can discuss the remaining things in the next class. Okay, just 1 minute. Let me take your attendance. Thank you, children. See you in the next class. Bye.